Good morning, students. So today we will learn about the types of chemical reactions. Already we have learned about combination reaction in my last video. Just to recap it. Combination reaction. What it was? Whenever any two elements, compounds or element and compound reacts, then it will form single type of compound. This is the general reaction for the combination reaction. If we take an example, suppose of two elements, then we will take H2 plus Cl2 gives you HCl. We will balance it. So whenever hydrogen and chlorine reacts with each other, then they will form hydrogen chloride. Let us take an example of two compounds. Suppose CaO, calcium oxide, and CO2. Whenever these two compounds react, then they forms calcium carbonate. It is already balanced, calcium 1, carbon 1 and 3 oxygen. So we will just name it C, carbon dioxide, and this is what? Calcium carbonate. Now if we take an example of one compound and one element, suppose carbon monoxide and oxygen is there, then they will form a single type of compound, that is CO2. We will balance it by keeping 2 here and by putting 2 here. So we'll name it again carbon monoxide, oxygen and carbon dioxide. Now this we have already learned in our last lecture. Now let us take a second chemical reaction, that is decomposition reaction. It is very simple. It is just a reverse of combination reaction. Here we have learned whenever two or more compounds or substances react, then they form a single type of compound, and this is called as combination reaction. Now what happened in decomposition reaction? A single compound breaks into two or more compounds or elements to give decomposition reaction. This happens in three ways. This can take place due to the heat, second due to the electric current, or when we provide electricity, then, or third one is when we give photo or light, not photo, we use light word, light or sunlight. If any reaction which takes place in the presence of heat or due to heat, that is called as thermal decomposition reaction. If it takes place due to the supply of electric current, then it is known as electrolytic decomposition reaction. And if it takes place in the presence of sunlight or UV rays also, we can say, then that is called as photolytic decomposition reaction. Suppose if we start with thermal decomposition reaction, and what are the example? Thermal decomposition reaction. So now we can easily define it as any reaction in which a single compound is breaked into two or more substances or compounds in the presence of heat, then that is called as thermal decomposition reaction. So we can take an example of, suppose, lead nitrate PbNO3 whole twice. This is the formula of lead nitrate. Whenever we heat this compound, then what will happen? Lead oxide plus NO2, nitrogen dioxide, plus oxygen. It is decomposed into 3 more compounds and elements. Now, if we see how it happens, let us draw one diagram here. Suppose if we take a dry test tube, and if we take lead nitrate in this, crystals of lead nitrate, how it looks? It looks white in color. It is a white colored compound. And if we supply heat over here, and this is the test tube holder for holding the test tube. What will happen if we heat it? Then this white colored compound decomposed into lead oxide, producing brown fumes, and this brown fumes takes place due to the formation of nitrogen dioxide. Plus from here oxygen gas will also evolve. So in this we can say that this brown fumes formation gives a test for the presence of lead nitrate in the reaction. Now second, here whenever this compound get heated, this compound will get converted into lead oxide by giving an indication with conversion of white colored compound into yellow colored compound. So formation of brown fumes and formation of this yellow colored compound tells that the lead nitrate decomposed into lead oxide, nitrogen dioxide, plus from here oxygen will also get evolved. So this was the example of thermal decomposition reaction. Let us take another example. Suppose ferrous sulfate, which is present with 7H2O, and it is called as ferrous sulfate hydrated form. Why it is called as hydrated? Because with this ferrous sulfate, hydrogen is also attached. So this compound become hydrated. So whenever we heat this, we heat the ferrous sulfate crystals, then what will happen? This ferrous sulfate will get anhydrated, forming an anhydrated compound. Next, if we further heat the ferrous sulfate, then what will happen? This ferrous sulfate crystals will get converted into ferric oxide, plus evolving two type of gases. Especially in this reaction, two type of gases are evolved, SO2 and SO3. If we name it, this is your ferrous sulfate, this is your ferric oxide, this is your sulfur dioxide, and this is your sulfur trioxide. Whenever you write an reaction, please mention the names. Now if we do it using a test tube, again we will take the dry test tube and we'll put the compound here, that is your ferrous sulfate. this one .7H2O, and if we heat it, then what will happen? This ferrous sulfate hydrated form gets converted into ferrous sulfate anhydrated form, and if you further continue heating, then what will happen? Here ferric oxide will be formed, and the compound here will become from green to it will become reddish brown. So here one color change will be observed, that ferrous sulfate, which is in green color, gets converted into reddish brown, and some gases here will also be evolved, SO2 plus SO3. So how we can identify these gases? This gases gives a very characteristic smell, that is a burning smell of sulfur. Okay. So here we can identify this reaction. How? Whenever ferrous sulfate is heated, it first converted from hydrated form to anhydrated form, and after that evolving two type of gases which gives characteristic smell of burning sulfur, that is SO2 and SO3, and one color change will be observed, that is from green colored compound it becomes converted into reddish brown colored compound. So this was the example of decomposition reaction, that is thermal decomposition reaction.